Sure.
Hello, everyone, and welcome back to the second edition of CLEAP Security Conference. So we have a wonderful set of speakers that has spoken till now, and going to speak in a couple of hours. We started CLEAPCon in 2021, realizing the need of cybersecurity out there. And since then, we have been bringing industry leaders, security experts, researchers, and from colleges as well, where people come, share their knowledge, and connect with like minded people. So, this conference has hosting so many wonderful people since past 2 years. And today we have been joined with such personality who would like to grace today's talk. Over to you, Pooja.
Thank you, Shivani. So our next speaker is very young, talented, and she's pursuing her final year. We are happy to see such people joining us today, and she's currently working as a security engineer intern at AppSecure Security, and she has keen interest in web application security, and she'll talk about blockchain and cryptocurrency, revolutionary technologies. So let's welcome Tanya Srivastav.
Thank you so much, Shivani and Pooja. Thank you so much for the warm introduction and the opportunity. It's great to be a part of the CLEAPCon. Having attended the first edition as an audience, I would like to do the justice as a speaker this time. And I will be discussing today, as Pooja said, blockchain and cryptocurrency, the revolutionary technology. And I think my screen is shared, right?
Yes, Tanya.
Okay. So let me start by quickly introducing myself again. Already Pooja has done that, but I'm pursuing my final year as a BTech student at VIT Bhopal University. I am pursuing a BTech in CSE with specialization in cybersecurity and digital forensics. I am currently interning as security engineer intern at AppSecure Security, and I have previously worked with them as technical writer as well. And I'm a cyber enthusiast, and I love to talk about topics relevant to cybersecurity. So the agenda for the day would be to introduce you all to the blockchain, the hot trending technology in the market. We will try to understand what is the need of it. We'll try to overview it and understand the working behind it. Then we will try to hop on to the cryptocurrency and understand the basics behind it as well. I think it's a lot of stuff to cover in 30 minutes, but we will try our best to do that. Okay, so before starting blockchain, let us go back to our centralized systems. So in real world, there are centralized system for, facilitating some processes. Like for transactional processes, there are bank. So now bank, the centralized system basically means that there is an authority or an entity that owns or regulates the system. It has the rights to the system. Now in the bank it has several clients, but the whole ownership, you can say, is with the bank, and the rights for the modification, rights to the access, all of it lies with the bank. So it is centralized, although clients connected to it do not get these access, and that is where some problem arises. First of all, like transparency, since there is no easy access to the system, the transparency is absent from this, and that is when the clients do not get the access, and it brings in untrustworthiness with this with the centralized system. And with the decentralized systems like blockchain, we are trying to combat that problem. So basically, we try to find the solution, that is blockchain, which gives us two main things: easy access, and the stuff must be hard to modify. Because when we talk about centralized system, admins have the access to the database and they can make a change. Right? They can make a change, and we will not be aware of that since the system is not transparent to us. But with blockchain, we have easy access to the database, and the database is really hard to modify. So it is decentralized. It is decentralized because no single entity owns it. No single entity is responsible for the regulation of the system, and that is why it is a peer-to-peer network. All the nodes present on the network, nodes are basically the devices that are connected to the network. So all nodes present on the particular blockchain network are a part of it and have access to it. So this is what blockchain is. It is a decentralized system. In detail, we will learn in the further slides. So let's go back to the history of blockchain, where it all started. It was 1990s, okay, so 30 years back, 3 decades back, when the research started on the topic. But the implementation has been done recently, only in 2009. When Satoshi Nakamoto, it is not clear if it's a single person or it's a group of people, they chose to remain anonymous, and they still choose to remain anonymous, who implemented blockchain for the first time. They discovered Bitcoin, the cryptocurrency, and made the first implementation of blockchain as a real use case in the real world. This is how the blockchain started, and it started with Bitcoin. However, nowadays there are a lot more usage in the real world that we will discuss later. What is blockchain? So if you go on to the Google and type it out, what is blockchain, you will most probably find this definition. We have taken it from the internet, but we will try to simplify it and understand it. So basically, blockchain is a shared immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. So first of all, we see that it is a ledger that has some properties, right? So what is a ledger? If we relate it with our real life, when there are shops, there are certain books they keep, where they keep all the transactional data related to the store, right? Those books are known as ledger. Okay, so blockchain is nothing but ledger, because that is a digitized database, you can say. But it is shared and immutable. That ledger is accessible to every node present on the network. Then it is immutable. It is immutable because the tampering is very hard. Okay, it is almost impossible. It is immutable, and what features make it immutable, we will discuss them in detail in further slides. It helps us in recording transactions and tracking assets in a business network. Now, this business network can be of real estate, can be of cryptocurrency, then it can be of medical departments. There are various business networks that are nowadays using blockchain to keep their data secure, because it brings with it the immutability and the integrity that is now in demand, since people are businesses and people are aware of the need of it, right? So blockchain is a shared immutable ledger. And what is blockchain? Blockchain is basically a chain of blocks, as we understand by the name. So if we try to relate it with a ledger, so if this is a whole ledger, and all those pages inside this ledger contain some data, right? So if we relate it with the blockchain, this whole ledger is a blockchain, which is the pages make this ledger, and similarly these blocks make the whole blockchain. And so blocks in a blockchain contain some data. Now, what data do these blocks contain? These contain transactional data. Basically, transactional data, if we okay, so for example, we are going to take the example of cryptocurrency in the context of cryptocurrency for examples, because we are going to discuss it later as well. But there are other business networks that use it, so keep that in mind as well. Okay, so for the transactional data, if you are talking about cryptocurrency, it may contain who sent the cryptocurrency, to whom it was sent, the wallet addresses, the keys, the proof of ownership, the time stamp, and everything. So every data relevant to the transaction is contained in this block, and then the hash of the block is contained within the block. Hash, for those who do not know, hashing is basically cryptographic puzzle, you can say. It is a cryptographic mechanism that if we give it a input, it will give us some unique output. We can treat that output as a code, unique code, right? So if the input is changed, the output will certainly change. That leads us to some great security features that we will discuss. So hash of the block is contained and hash of the previous block is also contained. So as we discussed, the blocks are all linked together. So what links them together are these hashes. So they play a great role in the technology, and let's discuss it here. Right. So as we can see, we are taking a small example. The hashes are actually a very long alphanumeric codes, but here we have simplified them to 11112222 for better understanding. So if we take this block, this is block 1, 2, 3. Now block 1 in any blockchain is known as Genesis block. This block will not point to any previous block, as it is the first block of the blockchain. Okay, and this hash, we can see that this hash is present in this block and this hash is present in this block. So all of this is linked through these hashes. This hash is pointing to this previous block and this hash is pointing to this previous block, and that is how all of it stays in order. Now if we try to do some tampering, let's think from a naive attacker's point of view, because he does not know what blockchain actually is. So if an attacker thinks that I will go and tamper some data in this block 1, okay, now if, as we discussed, if the block 1's data is tampered, block 1's hash will also change, because to every input there is a unique output. So if he changes the data, so 1, 2, 3, 4 will become the new hash, and now you see there is some inconsistency in the blockchain. Now this was linked through this hash, and since this hash has changed, it is easily traceable that some tampering has been done. Okay, and now if you think that okay, the block will remain changed like that, that does not happen in the blockchain, because when we will talk in detail about the working process of the blockchain, we will see that it follows a consensus rule. It is like every node present on the network. Okay, so suppose I'm a miner, I have mined this block, I have made this change. Okay, now I want to update it on the blockchain. I cannot update it myself. I have done the changes, I have done everything. Now I will put it out to the network, or rather broadcast it to the network for all of my other nodes to review it. Now when majority of other nodes approve it, that the block is mined correctly and it can be updated or added to the blockchain, then only the transaction will be said as completed, or the update will actually happen. But since all of the other peers will see this inconsistency, they will reject. Okay, they will obviously reject. And that is how this hash gives us the great security feature of immutability that is the dire need of the time. Okay, so this makes the tampering really difficult for the hacker. Now if you go on to say that I will change, if I have changed this data, I will also go on to change data in other blocks as well, that's fine, you can do that, right? But if you see from we take the example of cryptocurrency again, from the Bitcoin point of view, it takes 10 minutes to come to find out this hash and make the changes for single block, and blockchains are consisting of crores of blocks. If we go on to do that, it will take not million, actually hundreds of years, and that's not possible. Also it takes, even if the blockchain is a short blockchain, it takes so much computational power that it is very hard to update these, okay, to do this change. So it is practically impossible. And when we talk about owning the network, okay, so if you say that okay, I have changed this block, now my peers will approve it because I will own them. 50 51% owning you need in the network, or you need to own a computer that has 50 that is better than 51% of the people present on the network. You need that high computational power, and that is impossible. That makes the immutability, that brings in the immutability. And this is how the hashes become a great help in the technology. Okay, so moving on with it, we need a proof of work, right? So if this is done, there is a proof of work needed. So for any miner to mine the block, it needs to show that I have done some work, I have mined the block. The process that takes 10 minutes is actually proof of work. Proof of work is nothing but a process that determines where the miner will try to solve a cryptographical or mathematical, in layman's term, puzzle, and try to find out a number that is that has some constraints given by the blockchain system. And finding out that system or solving that puzzle actually takes up a lot of computational power. It takes a lot of time, that is 10 minutes for each block. Okay, so this is considered as proof of work. This shows that the miner has actually done something. And this is actually the reason why not everyone can become a miner or can do this stuff, because it needs some special, systems. Okay, so we talked about immutability. Now we read that it is a shared ledger. So it is a shared ledger because, as we talked about earlier as well, it is present, it is very transparently available to everyone on the network. Every node on the network can connect to each other, can download the copy of it. Okay, so if you want to know, actually you can download the blockchain file, the whole database, as a file on your hard drive. But then it needs so much storage that we cannot do that. And if for not every node actually can do that. There are some light nodes as well. They are known as light nodes because they do not download or keep a copy of the whole blockchain data, but they keep a copy of a part of the blockchain data. Right, so this is how it is distributed. And then we talk about the working of the blockchain. So basically, say Alice wants to send some bitcoins to Bob. Now Alice will create a transaction and it will use its digital signature. If we go into the detail of that thing, then it will take up a lot of time. So let's just say that it creates a transaction and puts it out on the blockchain network to be added to the blockchain and make the transaction happen. Now the user will initiate the transaction and broadcast it to the network, right? So what happens is that actually some miner will take up that transaction, will validate it, and now after validating it, it will actually put out that validated transaction in a block. Okay, so when a block is completed, then that particular miner will broadcast that block on the network for other nodes to verify it, as we discussed earlier. So here the consensus protocol will be applied, and that majority of nodes present on the network approve it, then the block is added to the blockchain. Otherwise it is rejected. So if there is some invalid data being composed as valid data, then it will come into the notice and that transaction gets rejected. So this is how the blockchain works, and blocks are added to the blockchain. So it brings with it some security properties. Immutability we have discussed in very detail. It's very hard to make changes. And then there is decentralized authentication. There is non-repudiation. And we talk about non-repudiation. So if we take a real life example, so for example, I give 500 rupees to my friend. Okay, now there is no data, no track of it that I have given my friend 500 rupees, and tomorrow he will refuse that, no, you did not give me those 500 rupees. So when he is denying the receiving of that asset, it is repudiation, and blockchain brings with it non-repudiation. Since every transactional data is present on the blockchain, the receiver cannot deny that I have not received that thing, okay, that asset. So this is how the non-repudiation is implemented with the help of blockchain. Now, accountability. So actually every user present on the blockchain is accountable, because everything is very, transparent, everything is out there, so you have to be accountable for your actions. You cannot just deny your actions. Now, availability is obviously the blockchain network is 24/7 available, and also with it the documents or the whole database is also available to every node present on the network. So from both perspectives, the availability is implemented. Now, obviously, there was a dire need of the blockchain technology in the industry, and with it comes the great benefits that it was required for. It brings in the great transparency. Everything is 100% transparent. Okay, so there is no double spending. So, what double spending means? Let's say that if I have an asset that is a land, okay, if I try to sell it to two people, I found two parties that are ready to buy that land. I take 50,000 advance from one party as well, and the 50,000 from other party as well, and there is no note of it. I have double spent my land. Okay, now if we are talking about money, then in the case of if the platform is not secure enough, the money can be double spended as well. That is, the same money can be transferred to two accounts. But the blockchain actually does not allow it. It does not allow it. How? Because if we are talking about cryptocurrency, if there is a bitcoin, every bitcoin is unique, or in layman terms we can say it has a unique code to it. So if Alice starts a transaction for sending $5 to Bob and $5 to Charlie, and Alice has $5 only. She is wishing that the whole both transactions would get successful, but it will not get successful, because what blockchain does is that as soon as the transaction is initiated, the blockchain will freeze those 5 bitcoins that Alice is trying to send to Bob. So as soon as she creates this transaction, her coins get frozen, and now you cannot do anything with these coins. So if since you cannot do any activity with it, double spending is not actually possible. Obviously there is enhanced security, because there is trustworthiness. You know that your data will remain, integrity of the data is maintained, and there is better traceability, because for example, when we talk about a use case of blockchain in real estate, so you have the whole history of that asset. If a land is being sold and then being bought, you have the whole you can trace the whole history from where the land was bought, to whom, then to whom, then to whom. So it is very traceable. Okay, so when we talk about traceability, if then there is a medical department, the trace is blockchain is of great use in medical department, because the medical documents are, if you do not know, medical documents of a patient are actually considered as sensitive and personal information. So it is remained secure with the help of blockchain, and only doctors have access to it, and doctors can access it anytime and all the time. So with that industry, this blockchain has also proved to be a great use case. Okay, now increased efficiency and speed of obviously your transaction will be much faster, since the middleman is not there, and then there is reduced costs, because when we talk about any industry nowadays, there are third parties, and those third parties take up a lot of fee from us, and so that is why the expense of that whole process, the cost of whole process increases. Now blockchain helps us reduce it by cutting down the middle agent, right? applications of blockchain. So there are many applications of the blockchain, as we have discussed. Cryptocurrency, there is supply chain, real estate, medical department. Supply chain is actually very useful because for food supply chain, you can actually trace when that particular food product was brought into the market, when the expiry date is, and from where it went to. There are certain levels of marketing, if you know, in the supply chain. So if it keeps on going, from which level the problem has come, if there is some problem to that product, because each level will keep tick marking the quality of the product and everything. So if there is some issue, from where it arose. Okay, so we have actually have just a few minutes left, and we have the topic of cryptocurrency. So we will try to cover as much as possible. And let's see that actually Alice is trying to send some INR to Bob, who actually stays in a foreign land where USD, we can say stays in US, where USD is actually the currency of the nation. But now in this process, the bank is the middle agent, because Alice will go to the bank with her INR, and they will exchange it into the international currency, and then that currency will be transferred to the Bob's account. So this creates a lot of tedious process, and as we know, bank processes are tedious, and it creates some problems, like there are very high international exchange rate. There is a lot of documentation to be done, and obviously the bank service is not always available, right? So we have all these problems, and to combat all these problems, Bitcoin or any cryptocurrency actually plays a great role. Now what happens is that Alice wants to send money. She will send Bitcoin, which does not need any conversion, be it anywhere. The Bitcoin stays Bitcoin, and the money gets transferred to the Bob. Okay, so this is how the middle agent is neglected from the scene. It does not matter, and the high international exchange rates are actually we can remove it from the process, because we see that the Bitcoin process costs very minimal fee. It has very minimal fee, so it's fine. It's fine. The fee compared to it is nominal. So what makes cryptocurrency actually valuable? Coin's utility. The coin is actually, it's not just a virtual thing that is made for fun. You can actually use it in real world. And when there is the utility of the coin, there is the value of the cryptocurrency. There is scarcity. You know why gold is more valuable than silver on earth? Because gold is much more rare to find than silver, and hence its value is more. So actually cryptocurrency, if we talk about blockchain, when the Satoshi Nakamoto implemented the blockchain into Bitcoin, they made some program that actually limits the Bitcoins to be available to only 21 million, and 19 million, I think, if I'm not wrong, 19 million of them have already been mined. So you see that it is not infinitely available, and when it is scarce, then the value increases. Demand, we know when Elon Musk tweet in the favor of some cryptocurrency, there is a boom in that industry, right? The value increases. So when the demand increases, value increases. And there is a difficulty of finding. We saw proof of work, how much a miner needs to work for it, and that makes the cryptocurrency valuable, because it is not very easy to find. Okay, so this is Bitcoin mining. We just discussed about it with the blockchain context only, that the process of creating a new Bitcoin is by solving a computational puzzle where it is a nonce number used only once, and it needs high-powered computers and systems to solve that math problems, and they are so complex that they cannot be even solved by incredible powerful computers. It can just be very difficult, and Bitcoin mining is actually necessary to maintain the ledger of transactions upon which Bitcoin is based, and that is very true, and we understand it now, right? So if we talk about miners rewards, so every miner gets some reward for mining a block. So if we see the value from 2009 when Bitcoin was brought into the market has declined throughout. So every 4 years, the miner's reward is said to be, changed or reduced to half. So in the 2009, 50 Bitcoins were awarded to the miner for the completion of one block. But now, from the latest rate of 2020, it is 6.25 Bitcoin per block only. So you can say you might have a question why there is a decline in the reward fee. But actually, if you think from the next slide, the Bitcoin price history in US dollars, that in 2010, the one Bitcoin value was actually equal to $0.1. And now latest data, if we see from 2017, then it's $4,000 now. That is 40,000 times. So the amount of Bitcoins have decreased, but the value has certainly increased. So this is why the rewards will keep decreasing as the time passes. Now there are certain challenges relevant to cryptocurrency. Obviously computational and memory requirement, which also actually leads to a lot of environmental pollution, and people are trying to actually find some better technologies because of this main problem. Then you must have an assumption, because there is consensus protocols, you must have interest that the people you have on blockchain, 50% of them at least are honest, otherwise the system does not mean anything, right? Then there is linkability of transactions and traceability of account holders. Since the accounts on the blockchain are semi-anonymous, actually the blockchain allows semi-anonymity of the holders. So the traceability of account holders is very difficult. You cannot actually do that. And then obviously, if the private key, we did not talk in much detail about the private key, so I will try to explain it very quickly. If Alice is trying to send 5 Bitcoins to Bob, so what Alice will do is Alice will create a transaction, and she will sign that transaction with her private key first of all. Okay, and with after that, it will sign the transaction or encrypt the transaction with the public key of the Bob. So the whole transaction can be decrypted only by the Bob with his private key. That is how the cryptography works. Okay. So use of these keys is very, very important in the blockchain technology. Now, if I have an account on the blockchain network, and if I lose my private key, then it will result in permanent loss of funds associated with that private key or that account. So this is a big challenge. So how to stay safe in this trading, Bitcoin or cryptocurrency trading? So I'll give out a few tips, a few basic tips that you must always follow there, where you can use a cold wallet. Cold wallet is nothing but a cryptographic, it is a wallet used for cryptocurrency storage, and it is actually not connected to the internet. So it is a cryptocurrency wallet that cannot be compromised because it is not connected to the internet. So you must always use a cold wallet, and you must always maintain multiple wallets, because it is said that if you use the same same wallet for every transaction, and if you do regular transactions on the blockchain network, then it is very easy to trace who the account holder is and what is its routine. From the routine, if someone is snooping on you, they might find out your identity. And this is actually theoretically said, and I also think that it is practically possible, because if say someone near to you, if they are keeping an eye on you, they might find out. So just use multiple wallets, so that that scenario is completely eliminated. And then obviously use secure internet services, so there can be no network attacks. They use a VPN and all. And then the last is to use mixer services. So what mixer service is, I'm sorry, I do not have an image relevant to it here, but I'll try to explain it out to you. What mixer service is it is a service where, if say A wants to send 10 Bitcoin to B, C wants to send 10 Bitcoin to D, and E want to send 10 Bitcoins to F. Now, if it can be sent directly also, okay, but then the traceability can occur. So to eliminate that traceability scenario, what these mixed services do is that they will send A's 10 Bitcoins to F, they will send B's 10 Bitcoins to C's 10 Bitcoins to B, and they will send E's 10 Bitcoins to D. So they are getting the amount, the receivers are getting the amount they need to receive, the senders are sending out the amounts they need to send. But these mixing services just mix those transactions so that it is less traceable in the future. It is not directly transferred, basically. So these mixed services are also available, but then you need to be sure of which part, third party is involved in this mixing services, because obviously if the service is there, someone must be behind it, right? So you need to be very, very aware of everything that you do over the internet, because since the cryptocurrency and blockchain have become very, very, very trending technology in the market right now, and everyone is talking about it, even our government, right? So with the increase in the boom and the trends, there comes a lot of responsibility, there comes a lot of danger. I do not want to demotivate you all with the cryptocurrency, but I would just like to advise to take all preventive measures, do your research, follow the people who are related to it, who have genuine knowledge, and then only take any step in the industry, because these days there are multiple applications that do frauds in the name of cryptocurrency, and you need to be very well aware of that. Okay, so that's all from me. I hope that I was able to infuse some of my knowledge to you, and it was a very fast paced presentation, but I hope that I was able to deliver what I wanted to deliver, and I hope that it was of use to all of you. You can get in touch with me over LinkedIn, or you can mail me anytime. I'm always available. So that was all from me. Thank you so much for being the audience and for being present and listening to me. If you have any questions, kindly pop it up.
Hey, thank you, Tanya. It was really wonderful listening to you, and it was a very insightful session as well. On the part where you spoke, like everything is transparent and everybody can see what all transaction that they are doing, and it actually makes things simpler. And as well as on the other hand, there are uh, uh, demerits of it. Yeah. And related to that, we have few questions. We can take it up. One question says, as everything is out open, how is the security aspect taken care?
Okay.
And one question, how are transactions and blocks encrypted?
Okay. So first question, I would like to say that, as I mentioned, that semi-anonymity is maintained in the blockchain. That is there. For example, if you go on to some applications that banks regulate or something, you will need to provide your KYC or something like that, but your real identity is actually not linked to your wallets. Your wallets have certain IDs, and from one ID to another, these transactions are made. So even if they are out in the open, you are not actually revealing your identity. So that is how that part is maintained. And now talking about the second question, I'm sorry, what was it?
No problem. I'll repeat that. How are transactions and blocks encrypted?
Yes, okay. So there are certain cryptographic algorithms that are used in the process. So for example, if we are talking about Bitcoin technology, then it uses SHA-256 algorithm, and these algorithms are cryptographically very, very strong, and they provide very good encryption. So no need to worry about that.
All right. Thank you. Thank you so much, Tanya, for taking your valuable time out and speaking with us today on blockchain. I believe everyone who is listening or will listen in the future will definitely be benefited. You have simplified it out to a extent. Thank you. And I hope to see you next year as well.
Thank you so much, Shivani, for having me. It was my pleasure and honor. And now I will use it as an achievement to tell everyone that I was present at the FleepCon. And it's going great. And all the other sessions are so insightful. And I hope that the audience remains there and listens to them. Thank you so much for having me.
Thank you. I'm humbled. Thank you. Bye-bye, Tanya.
Bye. Thank you.